And this is where things got bastardized because I did it first. And what it was I was pushing electrical signature and motor circuit analysis and current signature back when I was with a company called Alltest. And I used this as a way to pitch that our technology could see things sooner, and I would use specific failure modes. Okay, and that's basically where it went, is all the marketers, vibration, ultrasound, whatever technology came in, and they said, you want our technology because it detects everything the soonest. And they would, of course, put their technology as the furthest back away. I always found it interesting, though. The vibration and ultrasound guys never include ESA. That's because we are so far to the left on virtually everything they detect as to be ridiculous. And I can laugh at this point, but it's true. So in any case, we'll detect a change in a bearing at 1 watt or less. No. You're not going to see temperature or hear it until you're at tens of watts. So in any case, I come here and even in the high frequency range. So I come here and I would apply then and say, okay, bearing failure, an electric motor, and bearings, because bearings are wrongly 51% of all failures, because a study in 1983 tells me so. So I'm going to use this chart from that study, which is completely misconstrued and incorrect, and I made the same mistake. I followed people that published that until I got the actual data, because they called them EPRI studies. They were actually IEEE studies that were done. One of them was done, the 1983 one, on large medium voltage motors in power plants that has somehow been applied to everything. And they said 51% of failure. Now, it had to do with repair reports after a repair was done. So if I take an electric motor and I send it into a repair shop, whether or not there's anything wrong with the motor, and they tear it down and inspect it, what do they do every single time? If I have ball or roller bearings, they replace them. So whether there's anything wrong with the bearing or not, they get replaced. Yep. 1/3 of the motors sent in, according to the study, had nothing wrong with them. So that number is completely skewed. Now, rewind. That I don't just randomly do unless it's called for. And at power plants, especially in that time period, after so many years of operation, say 10 years of operation, if it was a critical machine they pulled out, they would automatically wind it. It was wound whether it needed it or not. Okay? So all the numbers are skewed there. So I redid that as a different presentation based upon the original studies, because there was one every decade. So 1983 had a 1974, had a 1964 to 1954, and then there was a 1995 version that was done on smaller electric machines and metric on offshore platforms, such as oil rigs. So they would, of course, throw in bearings into this and say, because, an electric motor and pump fail, the only reason they possibly could fail is due to bearings, and look, my technology will detect it sooner than their technology, therefore you need to buy our product so you can detect bearings, which are less than half of the failures, and you don't have to worry about any of that power quality stuff, electrical discharge stuff, all the other things that drive that bearing failure. You want to do unconditioned tasks to detect a failure, not to mitigate it, but to detect it. I'm going to let that sink in. You are being sold by virtually every technology that the sole purpose of this is to detect a failure, not to fix it, not to mitigate it, not to stop it from failing, but to detect a failure. That's why we see in LinkedIn all of these bearings that are completely destroyed, and everybody points at it, especially all these new investor-owned companies, going, look, we caught this. And we're going, hell, we could have heard that 2 blocks away. But that's neither here nor there. Chances are the actual detection was somebody walking by.